Welcome, YouTubers. In this video, we're going to take a closer look at 10 very easy arithmetic reasoning practice test questions that should help you prepare for both the Armed Services Vocational Aptitude Battery, that is the ASVAB, as well as the pre-screening Internet-Delivered Computer Adaptive Test. Let me just say this, since these are very easy practice test questions, you should be able to answer all 10 of them very quickly and accurately. That is to say, it should take you less than 15 minutes to answer all 10 of these questions correctly. In order to get the most from this video, of course, you'll want to pause the video after I read a practice test question, attempt to work out the practice test question on your own, and then resume playing the video to check your solution. As a reminder, on the actual ASVAB and PiCAT, you're not permitted to use a calculator or a reference sheet. So as you work your way through these practice test questions, try not to use any of those resources. Finally, I want to mention this. Both the ASVAB and PiCAT are computer adaptive tests, which means that the questions that you see in the beginning of the test will be as easy as the questions you see in this video. You want to get those questions right, and you want to spend as little time on those questions as possible. That way you can get to the harder questions later on in the test, and that way you can spend more time solving those harder questions later on. In other words, please don't think that the entire ASVAB and PiCAT will be as easy as this video. Again, those are computer adaptive tests. They get progressively more difficult depending on how many questions you answer correctly early on. So with all that finally being said, let's go ahead and get started with this practice test. So this first question says a sweater, which was originally priced at $80, was marked down by 25%. What is the sale price of the sweater? So if you watched my video yesterday, you know we're going to be finding the sale price of the sweater. And that's going to be equal to the price of the sweater minus the discount times the price. Of course, we know the price as well as the discount that we're being given. Originally, this sweater cost $80, so we know our price is going to be $80. So let's go ahead and plug that in right here. And of course, we know our discount is in the amount of 25%. To use this right here, we have to convert 25% to decimal form. Of course, the decimal equivalent of 25% is 0.25. This is times price, which we know is 80. All right, so by doing this simple arithmetic, we'll have our answer. To start, we're going to do 80 times 0.25. We're multiplying a whole number by a decimal, so what you want to do is shift this decimal in 0.25 2 times to the right to clear it. That makes this problem 80 times 25, albeit with 2 decimals to shift back into the left at the end. 0 times 5 is 0. 5 times 8 is 40. Before we start multiplication with this 2, we have to bring in a 0 placeholder. 2 times 0 is 0. 2 times 8 is 16. Add these together. 0 plus 0 is 0. 0 plus 0 is 0. 4 plus 6 is 10, so bring down a 0 and carry a 1. 1 plus 1 is 2. Bring our 2 decimals back in. So this becomes 80 minus 20. And of course, 80 minus 20 is 60. So the price of this sweater after our 25% discount is applied is $60. All right, so number 2 says, if a student bought a sandwich for 80 cents, milk for 20 cents, and a pie for 30 cents, how much did the meal cost in total? So I know that many of you could solve this one mentally. That said, on test day, you may be a little bit nervous. And for that reason, you may want to work this one out by hand. So we're just adding these things up. Of course, you should know that 80 cents expressed in decimal form is this, 0.80. Likewise, 20 cents in decimal form is 0.20. And finally, 30 cents is expressed as 0.30. We're just going to be adding all these together to get the total cost of the meal. 0 plus 0 plus 0 is 0. 8 plus 2 is 10 plus 3 is 13. So we're going to drop down a 3 and carry a 1. Of course, we're going to bring our decimal down as it is. 1 plus 3 zeros is just 1. So this total meal cost $1.30. All right, so number 3 says if a box of screws weighs 1 and 5/6 pounds, then what is the weight of 12 boxes? So we know our box of screws weighs 1 and 5/6 pounds. We want to know how much 12 of those boxes weighs. So of course you could do 1 and 5/6 plus 1 and 5/6 plus 1 and 5/6 12 times. Of course, the easy way is to realize that repeated addition is simply multiplication. So we could do 1 and 5/6 times 12. Okay, so now we have a mixed number. As you can see, 1 and 5/6 times a whole number, notably 12. So to multiply these two together, we have to convert them to a common unit. And it's going to be very easy to convert both 1 and 5/6 as well as 12 to improper fractions. So let's go ahead and do that. So to convert 1 and 5/6 to an improper fraction, our denominator is going to stay the same. But our numerator is going to be found by doing this. 1 times 6 is 6, plus 5 is 11. Of course, we're multiplying that by 12. To write 12 as an improper fraction, we're just going to place it over 1. So this is 12 over 1. Now we're just multiplying two improper fractions or two fractions together. When you multiply fractions, you just multiply straight across. That said, if we multiplied straight across, and let me show you what that would look like, that would be this: 11 times 12 over 6 times 1. I don't want to work out 11 times 12 and then divide that by 6. That would be too much work. So instead of taking this approach, I'm going to do this. I'm going to say 6 goes into 6 one time, 6 goes into 12 two times. That is to say, I'm going to cross reduce this. All right, so now I have 11 over 1 times 2 over 1. 11 divided by 1 is 11. 2 divided by 1 is 2. You should know that 11 times 2 is 22. So the correct answer to this one is D, 22. All right, so number 4 says this: if a 5-foot pole cast a shadow of 8 feet, and at the same time a nearby tree cast a 48-foot shadow, then how tall is that tree? So for a problem like this, it might be helpful to make a quick sketch. Again, we know we have a pole that is 5 feet tall, and according to this problem, it casts a shadow that is 8 feet long. Likewise, we know that there is a tree nearby, and it casts a shadow that is 48 feet long. That said, we want to know how tall this tree is, and since that's currently an unknown, we can represent the height of this tree with a letter variable. In fact, we could call it x feet tall. You should recognize what's more that these are nothing more than a pair of similar right triangles. And to figure out unknowns with similar figures, you can use a ratio. A ratio, again, is two fractions that are equivalent. And let's fill in this left-hand side. Again, we're comparing the height of something versus the length of its shadow. Well, the height of our pole is 5 feet and the length of its shadow is 8 feet. This ratio should hold true for the height of the tree as well. Again, the height of the tree is x feet tall. The length of its shadow is 48. So by solving this ratio for x, we'll be able to determine what the height of this tree is. Of course, to solve ratios, you just do some simple cross multiplication. We're going to do 8 times x to start, so that's going to be 8x equals 5 times 48. Let's work this off to the side to simplify this a little bit. We have 48 times 5. 8 times 5 is 0. Carry 8 times 5 is 40. Bring down a 0, carry a 4. 4 times 5 is 20. Plus 4 is 24. So this is 8x equals 240. Now we're just solving for x, which is the height of the tree. So to do that, we're going to divide both sides by 8. In doing so, we get to cross this out. And you should be able to do this mentally. 24 divided by 8 is 3. Therefore, 240 divided by 8 is going to be 30. So the height of our tree is 30 feet. All right, so number 5 says this: if the perimeter of a square garden is 84 feet, then what is its area? So since we're working with both the perimeter and area of a square, I'm going to write down those formulas very quickly. Again, to find the perimeter of a square, it's side plus side plus side plus side. Again, squares have 4 sides. All those sides are s long. To find the area of a square, it's simply one of those sides squared. All right, so let's see what we know about this square. We know the perimeter of our garden, our square garden, is 84 feet. So P equals 84. Of course, we can go ahead and plug that into our perimeter formula. This becomes 84 equals S plus S plus S plus S. Now you might be saying to yourself, well, don't we need S to find the area of this square? Yes, we do, and that's very easy to figure out. Again, this is S plus S plus S plus S. There are 4 s's there. Now it should be pretty obvious that we can solve this for s by dividing both sides by 4. This crosses out, leaving you with s on this side. This you should be able to do mentally as well. 8 divided by 4 is going to be 2. 4 divided by 4 is 1. So we can see that the side length of our square is 21 feet. And if you need to see that visually, again, in squares, all the sides are equal. This would be S, this would be S, this would be S, and this would be S. We now know that the side length of our square are 21 feet. So these are all 21. Now all we have to do is find the area of this square. We know S is 21, so this is going to be 21 squared. Of course, you should know that 21 squared is the same thing as 21 times 21. And let's go ahead and work that off to the side so as not to make any mistakes. We have 21 times 21. 1 times 1 is 1. 2 times 1 is 2. Before we start multiplication with this 2, bring in a 0 placeholder. 2 times 1 is 2. 2 times 2 is 4. Let's add these together. 1 plus 0 is 1. 2 plus 2 is 4. 4 plus nothing is 4. So the area of this square garden is 441 square feet, which you can see is answer choice C in this case. Number 6 says this: there are 9 red and 6 green marbles in a bag. If a child reaches in the bag and randomly takes out 1 marble, what is the probability that that child got a green marble? So, this is a very basic probability question. I'm going to set it up formally, but most of you can solve this one fairly quickly without doing the formal notation. The probability of getting a green marble is going to be the number of green marbles in the bag divided by the total number of marbles in the bag. And that's fairly easy to figure out. How many green marbles are in the bag? There are 6 of them. How many marbles are in the bag in total? Well, there are 9 red and 6 green. So in total, there are 15 marbles. So this is 6 over 15. So their odds of picking a uh, green marble in a bag of 15 marbles is 6 over 15. Of course, that's not one of our answer choices, which means we have to convert this to a decimal and then a percent. Uh, Before we do that, let's go ahead and try to reduce this fraction to make the work a little bit easier to do. You should recognize that 6 and 15 have a common factor of 3, which means we can divide both 6 and 15 by 3. 6 divided by 3, of course, is 2. 15 divided by 3 is 5. Many of you know that 2/5 is 40%. If you know fractions, you know 2/5 is 40%. But how could you figure that out in the event that you didn't know that? Well, you can convert this fraction to a decimal by performing this long division. Again, you can read this as a fraction as 2 over 5, or you can read this as long division, notably as 2 divided by 5. And by doing this long division, we can go ahead and make this into a decimal. How many times does 5 go into 2? It doesn't. So I have to add a decimal here and a 0 here. Soon as I add that decimal, I have to bring it up in my answer. And since 5 did not go into 2, I'm going to place a 0 there to indicate that 5 did not go into 2. How many times does 5 go into 20 without going over? 5 times 4 is exactly 20. 20 minus 20 is 0. So 2/5 is the same thing as zero point 0.4. How do you convert decimals to percents? You just multiply them by 100. When you multiply a decimal by 100, all you do is you take that decimal and you shift it to the right 2 times. So let's do that. Zero point 0.4 times 100. There are 2 zeros in 100. We're going to take its decimal and shift it 2 times to the right, and we're going to add a 0 placeholder. So this is 40%, which is answer choice B. All right, so number 7 says this. A certain bag of potting soil is 1/4 peat moss and the rest is dirt. What part of the potting soil is dirt? All right, so you should be able to do this one mentally, and you should be able to say that if a bag is 1/4 peat moss, that means 3/4 of it is dirt, 3/4 is 75%. That said, if you couldn't do this one mentally, I'm going to work it out by showing you all the steps. Again, let this one refer to the bag, and we know that 1/4 of this bag is peat moss and the rest is dirt. So by doing 1 minus 1/4, we'll figure out what fraction of this bag of potting soil is dirt. Of course, we're subtracting a whole number by a fraction here. So what you want to do is convert this whole number to a fraction by placing it over 1. And to subtract fractions, they have to have the same or a common denominator. We have a denominator of 1 here and a denominator of 4 here. Common denominator between 1 and 4 is going to be 4. So we're going to rewrite one of these fractions so that it has that common denominator of 4. To write 1 is 4, we're going to multiply it by 4. We're also going to do that to its numerator. 4 times 1 is 4. 4 times 1 is 4. So 1 is the same thing as 4 divided by 4. Again, 4 divided by 4 is 1. And of course, this already has a denominator of 4, so we'll just bring it down as is. When you subtract fractions, this is all you do. You just subtract their numerator. So it's going to be 4 minus 1 over 4. 4 minus 1 is 3, so this is 3/4. Of course, you have to convert this to be a percent, and we just did that in a previous problem. Again, you should know that 3/4 is 75%. You should know that 1/2 is 50%. You should know that 1/4 is 25%. You should know those common conversions. But in the event that you did not know that 3/4 was 75%, you can, of course, do this long division off to the side. So as a fraction, we read this as 3 over 4. As long division, we read this as 3 divided by 4. Now we ask ourselves, how many times does 4 go into 3 without going over? It doesn't, so I have to add a decimal and a couple of 0 placeholders. I'm going to bring my decimal up into my answer, and I'm going to put a 0 above this 3 to indicate that 4 did not go into 3. Now the question is this: how many times does 4 go into 30 without going over? Well, 4 times 7 is 28, and 30 minus 28 is 2. Let's go ahead and drop down this 0 placeholder. 4 goes into 25 times. 4 times 5 is 20. 20 minus 20 is 0. All right, so 3/4 is 0.75. Again, to convert a decimal to a percent, you just multiply it by 100, which means you just take its decimal place and you shift it 2 times to the right. So 3/4 is 0.75, and that's also 75%, which is the answer choice C. All right, so number 8 says this: if 35 of the 140 cars delivered to a car dealership were blue, what percent of the cars were blue? All right, so you should be able to say this: 35 of the 140 cars delivered to the dealership were blue. So what you're going to have to do in this case is convert this fraction into a decimal and then into a percent, as you can see, to get your answer. Thankfully enough, We did that for the previous two problems, and it's almost as if I planned this practice test that way. So let's go ahead and work on doing that. You should recognize that we can reduce this fraction to make the work a little less intimidating. More specifically, you should recognize that 35 as well as 140 are both divisible by 7. 35 divided by 7, of course, is 5. And 140 divided by 7 is, well, what is 14 divided by 7? That is going to be 2, and just tack on that 0. Again, you could also simplify this fraction a little bit more by dividing 5 as well as 20 by a common factor of 5. 5 divided by 5 is 1. 20 divided by 5 is 4. So as I just mentioned, you should be able to say that 1/4 is 0.25, which is 25%. So the answer to this one is C. 25% of the cars delivered were blue. That said, if you want to see me work this out the long way, we would read this as long division, notably as 1 divided by 4. We say, does 4 go into 1? It doesn't, so I have to add a decimal and a couple of 0 placeholders. Since 4 did not go into 1, we'll put a 0 here, and of course we got to bring up our decimal into our answer. How many times does 4 go into 10 without going over? Of course, that's 2 times. 4 times 2 is 8. 10 minus 8, of course, is 2. Drop down this 0. 4 times 5 is 20. 20 minus 20 is 0. So again, that's how we got 0.25 from 1/4. Again, to convert a decimal to a percent, you just move its decimal place over 2 times and tack on that percentage sign. All right, so number 9 says this: the sales staff at a local car dealership sold 5, 7, 7, and 3 cars for each respective week in February. If there were 92 cars on the lot at the beginning of February and 96 cars on the lot at the end of the month, then how many cars were delivered to the lot during the month of February? All right, so the first thing I want to figure out is this: if there were 92 cars on the lot at the beginning of February, and this number of cars were sold during February, I want to figure out how many cars were left after all these cars were sold. So that's going to look like this: 92 minus, again, 1 week they sold 5, so we'll subtract 5. Another week in February, they sold 7, so we'll subtract out 7. Another week, they sold another 7, so we'll subtract out another 7. And another week, they sold 3. So by doing 92 minus 5 minus 7 minus 7 minus 3, we'll know how many cars were left on the lot during the month of February after this number of cars were sold. Of course, it's going to be easy to combine these into just one number. You should know that 5 and 7 is 12. Likewise, you should know that 7 and 3 is 10. So this becomes 92 minus 12 plus 10, which is 22. All right, let's go ahead and do this subtraction real quick. If you can't do that mentally, you can always do it off to the side. 92 minus 22. 2 minus 2 is 0. 9 minus 2 is 7. So here we have 70 cars on the lot after these 22 were sold during the month of February. Well, we were told that at some point during February, uh, the number of cars on the lot went up to 96 because they had a delivery. All right. So if no cars were delivered and they sold these 22 cars, they would be down to 70 cars. That said, they had a delivery that brought them up to 96. So to answer this question, and to answer how many cars were delivered to the lot during the month of February, we have to find the difference between 96 and 70. That's pretty easy to do. 6 minus 0 is 6. 9 minus 7 is 2. So at some point during the month of February, 26 cars must have been delivered to the lot, because otherwise they would have been left with 70 cars on the lot. So 26 cars were delivered. The answer is B. All right, so number 10 says this: a pizza is cut into 8 equal pieces. A person who eats 1/2 of one piece eats what fraction of the pizza? So for the purposes of this question, you have to imagine that a pizza is a perfect circle. And similarly, you have to be able to visualize the fact that it was cut into 8 equal pieces. Well, that means that each piece of this pizza represents 1/8 of the total pizza. And again, I know some of you could probably solve this one mentally and without having to do any of this work whatsoever, which is great. That said, I'm going to show everyone the logic behind this. So each slice represents 1/8 of the total pizza. According to this problem, we want to figure out what uh, what fraction of the total pizza half of a slice is. So we're going to take one of these slices and we're going to cut it in half. So in other words, we have to figure out what 1/2 of one of these slices is. Well, one of these slices is 1/8 of the pizza. So we're going to take 1/8, we're going to multiply it by 1/2. Of course, we're just multiplying two fractions here, so we're going to multiply straight across. So this is going to become 1 times 1 over 8 times 2. 1 times 1 is 1, 8 times 2 is 16. So a person who eats half a slice of this pizza eats 1/16 of the total pizza. All right, so that is it for this video. As always, I hope you found it helpful. And as usual, you're more than welcome to leave feedback in the comment section below. Of course, I want to stress this again. These are just the very, very easy practice test questions. And for that reason, you shouldn't expect your test to be as simple as this one was. Again, the ASVAB and PiCAT are computer adaptive tests, which means that if you get these easy questions right in the beginning of the test, you will start seeing more and more difficult questions. That's a good thing because the more difficult the questions get, the higher your AFQT score is going to be. That said, I want to mention this in closing. I do have a playlist called Free ASVAB / PiCAT Math Bootcamp playlist. As you can see, it has more than 500 practice test questions, and it has practice test questions for both arithmetic, reasoning, and math knowledge. If you go through this playlist from start to finish, you will be exceptionally well prepared for both the ASVAB and PiCAT. Of course, this playlist is completely free. It's available here on YouTube. And for that reason, I'll post a link to it in the description of this video. If you want to help my channel out, you can do one of two things. One, you can, of course, subscribe to it. And two, you can share links to my videos, including this video, on social media, including on Facebook and Twitter. And on that note, I'm going to go ahead and cut you loose.
Konnichiwa.